Hello, myself Shikha from the Department of Data Science, and today I will be presenting a literature review on titled From Explainability to Trust, a structured review of multimodal XAI and MLLM interpretability. Here, MLLM stand for Multimodal Large Language Model. Moving toward the content, I will be talking about overview, foundations, interpretability in multimodal large language models, from attribution to reasoning, toward trustworthy multimodal XAI, challenges and future directions, conclusion and references. So now moving towards the overview of multimodal AI and explainability. Multimodal AI refers to the system that can process different type of data such as image, text, audio into unified model. With the rise of multimodal large language model, these systems are now capable of performing complex tasks like visual reasoning and cross-modal understanding, and are widely used in areas like healthcare, autonomous system, and science. But as there are so many challenges as well, as this model become more capable, they also become more opaque. We often call them as a black box or black box problem, because the way they refuse different data types happens in a complex mathematical space that we can't easily see into. So this makes it difficult to pinpoint exactly which piece of information, whether it was a specific word or a specific pixel, drove the final decision. And in high stake environment, we need to know that these decisions are grounded in reality and free from hallucinations. So this is why there is a need for explainability. It's not just a nice to have feature, it's a fundamental requirement for accountability. It's the bridge that allows us to verify the model's logic before we act on it. So here is the diagram. If you look into the diagram, there's a three part: data explainability, then model explainability, and the post hoc explainability. So what happened at data explainability is data are collected and then they are analyzed and they are cleaned, passes to the model model explainability, where it goes through the structural explanation and it gives the behavioral explanation. It goes in two way. It tries to give the result into it try to result give the explanation in two different ways. So if we look at the framework on this side, we will see the reasons they are addressing. This is a design system that don't just output a prediction in a vacuum, but simultaneously generate a clear rational explanations, giving us a window into the model's reasoning. Here at the post-hoc explainability, it explain why the models gives the particular explanation. Now moving towards the foundation of multimodal XAI, it refers as a synergy between complex data fusion and human-centric transparency. It is the mechanism that reveal exactly how disparate modalities like vision, text, and audio are collaborating to give predictions or classification. So when we look at the trajectory of the field of evolution of MXAI, which is multimodal explainable AI, it has moved from traditional to deep learning to foundation and generative LLMs. So in traditional ML, which was interpretable but limited, as in traditional ML, it explains why, for example, heat map. It shows the heat map, but which is not all the time explained properly to the humans. It's not clearly at the same time. The person who does not have a domain specific knowledge, they won't be able to understand this heat map. So towards the deep learning era, we traded transparency from raw. It improved the performance and reduced the transparency. And today, with foundation models and generative AI, we are finally reclaiming that logic, which is with logic through reasoning based explanation, such as COT, a chain of thought. So this has led to a sophisticated taxonomy of methods. So this taxonomy, now we utilize post hoc, like gradient based perturbation methods, which is like forensics to probe a model after a decision is made, and intrinsic architecture like attention mechanism, where the model is self-explaining by design. Ultimately, the goal is grounding, which ensures that every output is no longer a black box guess, but a justified logic path anchored in a verifiable evidence. So here the picture shows a architecture analysis method into 3 types, which is unimodal, multimodal, and interactive explanation model based on explanations, modalities, and control signal acceptance. So first, in the unimodal explanation, this is the basic model. The model gives an answer and points to the heat map of pixels. It shows us where it looked. This model, where this model looked, it shows where this model looked, but it doesn't explain why it reached that conclusion. It is a clue but not a full reason. In multimodal explanation, this is a major step forward because the model provides a textual explanation alongside the image. It actually articulates its logic, explaining that it sees toothbrush in the mouth. We can now verify if the model's chain of thought matches the visual evidence. And in the last interactive explanation, this is human in the loop approach. A user can point to a specific person or object in the frame, and the model provides a tailored explanation for the exact selection. Moving towards the interpretability in multimodal large language model, MLLMs can change the game because they do not just process multiple modalities like text, image, or audio. They also integrate multiple modalities with language reasoning. They also generate explanations as part of their reasoning. This represents a shift from a simple feature attribution to more reasoning based interpretability. So interpretability in LLMs can be understood at 3 levels: data level, model level, training level. So at data level, we look at how different modalities such as text and audio, video are aligned and represented. At the model level, we analyze internal components like attention mechanism, embeddings, and even neural level behavior. At the training level, interpretability comes from alignment method, supervision, and fine-tuning strategies that guide the model toward more explainable outputs. And in the cross-model reasoning, it just joint understanding of vision and language, chain of thought for step-by-step reasoning, and link perception, which link the image with logical interface text. Moving towards the overview of LLM, here in this figure, there are 3 distinct operational levels. First is modeling representation, where multi-models images, here the images is there and 2 inputs are being passed. One is image, one is text. Text is what color is mentioned along with the image. So now images are going through the encoder, text are also going through the encoder, and it passes through the multimodal. Related metrics is going to the attention in the first multimodal one, not this one. In the first modeling representation is going to obtaining explanation, where it's going to the evaluation based explanation. So in the evaluation based explanation, here we see probes. Here we see probes to understand how the model represent image and text as an embedding. The image and text went through here, it changed into embedding by iteratively evaluating here. Here by iteratively evaluating, it verifies if the model truly understands the task, such as identifying the color of the shirt, or it's simply reacting to a data noise. Second, we move to this important Bayes mechanism. Here, this is where it analyzes the internal behavior of the model by using attention algorithm like GradCam or LavaCam. Finally, the most advanced layer, which is a concept based explanation. Here it uses decomposition method to break down complex representation metrics into human readable concept like yellow shirt, men. This represents a fundamental shift from simple feature attribute to reasoning based interpretability. Ultimately, this framework allow to audit the model at the data model and training levels, ensuring that the chain of thought in the text is perfectly aligned with the visual perception and that can be seen in the data. Moving toward from attribution to reasoning, which is a paradigm shift. So it highlights a key paradigm shift in multimodal explainability from feature attribution to reasoning based explanations. Traditionally, explainability method focus on feature attribution, where the model highlights important regions or input such as pixel or words that influence the prediction. However, these model methods only tells what the model is focusing on and why it makes a decision. Attention versus reasoning. Attention shows where the model focus does not guarantee why a decision is made. Reasoning provides logical explanation of the decision, and explanation generated as a part of model output, combine perception plus reasoning, and moves from post hoc explanation to in-strict explanation. So this brings to the limitation of attention mechanism. While attention shows where the model is looking, it does not necessarily provide a causal or logical explanation. So in other words, we can say attention is not always equal to reasoning. Now modern multimodal large language model may beyond this by generating explanations through chain of thought reasoning. Instead of just highlighting features, the model explains its decision step by step, making the process more interpretable and human understandable. So here in the image, this diagram shows different type of multimodal fusion architecture. At the top, we see early fusion approach where inputs from different modalities are combined. Here, different modalities are combined at the beginning and processed together. This simple but often lacks interpretability. In the middle, hierarchical fusion process, not in the middle, here hierarchical fusion process modalities in stage, allowing more structured interaction. At the bottom, we see cross attention mechanism, single cross attention mechanism, multi cross attentions. Here, where only it modify these modalities attend to another using query, key, and value representation. They interact with each other using this key, value, and query. This cross attention module, these are the two different modules which share the cross attention. So this is the key component in the transformer based model and enable deeper interaction between modalities. However, even with this advanced attention based architecture, the explanation is still limited to where attention is applied. It does not fully explain the reasoning behind the final decision. This is why the field is shifting toward explanation as generation, where model produce reasoning in natural language, combining perception and logic to provide more faithful explanations. Now moving towards the trust gap in multimodal AI, which highlight that multimodal often generate output that sound convincing but not grounded in the actual input. This is known as hallucination, where the model produce plausible but incorrect outputs, mismatch between generated text and actual visual input. Now looking at the figure, it illustrates the evaluation challenge in explainable AI. We see three categories of evaluation method, which is quantitative, qualitative, and objective. Ideally, a good explanation method should balance all these three. However, most existing approaches are concentrated in only one area. For example, a large number of methods fall under qualitative evaluation, which focus on human judgment but lack standardization. Some methods are objective or quantitative, but they fail to capture human interpretability, and this overlap between these categories is very limited, as shown by the small intersection region in the diagram. This indicates that very few methods can simultaneously achieve all these three aspects. This imbalance highlights the evaluation crisis as there's no unified or reliable framework to assess whether an explanation is truly correct, meaningful, or trustworthy. As a result, even if model provide explanations, we still cannot fully trust them. So toward trustworthy multimodal XAI, here we have three building. It focuses on building trustworthy multimodal explainable AI by combining insights from all the three papers. I have used three papers for this review. So the key requirement for the trustworthy system is grounding. This ensures that the model outputs are directly linked to actual evidence in the input data, such as specific reasons in an image or relevant parts of the text, reducing unsupported or hallucinated claims. The next important component is self-verification. In this process, the model does not just generate an output, but also checks its own reasoning against the original input. This helps in identifying inconsistencies and reducing hallucination, improving the reliability of the explanation. Finally, we have this human-centric evaluation. Here it focuses on interpretability for end users. This is especially important in high-stake domains where decision must be interpretable by experts. Together, these three components, grounding, self-verification, and human-centric evaluation, represents a shift towards more reliable and trustworthy multimodal AI. Moving towards the challenge and future direction. So first, efficiency remains a major concern. Multimodal models, especially large language models, are computationally expensive and often slow, which creates challenges in real-time application. At the same time, adding explainability increases overhead even further, because so there's a need for more lightweight and efficient interpretability methods. Second is standardization. This is still missing in the field. There's no unified framework or benchmark to evaluate explanation consistently across different models. Most current metrics are inconsistent and often measure fluency rather than true explanation quality, making comparison difficult. Finally, neurosymbolic integration. This is an important future direction. This involves combining neural network based learning with symbolic reasoning system. The goal is to improve logical consistency in explanations, which can reduce hallucination and make model explanation more structured and causally meaningful. Together, these challenges highlights the need for more efficient, standardized, and logically grounded approaches in future of multimodal XAI research. So the conclusion is XAI is moving from post-hoc visualization to in-strict linguistic reasoning. Attention mechanisms remain powerful but require caution interpretation. That's all. Thank you.